In this tutorial, we are going to try solving more applications in order to find the derived function of the function f of x equal x to the power n, where n belong to R or any real number. For this purpose, we are going to example 5, page 119. Find the derived function where f of x equal part A, B, C, D, E, and we will add later on part f. So when f of x equal x to the power n and n belong to any real number, then the derived form of prime of x equal n the power multiplied by x, and we reduce 1 from the power. Let's start applying this form in part A. Then in part A, f of x equal to x power 6. Then this is in the same form of x power n. We can say n equal 6. Then applying the rule f prime of x equal n, that is 6, multiplied by x to the power 6 minus 1, that is 5. Now let's go to part B. B, f of x equal x to the power 1 over 2. Then n equal 1 over 2. Therefore we say f prime of x equal 1 over 2 n multiplied by x to the power n minus 1, that is 1 over 2 minus 1 equal to minus 1 over 2. By substitution, it will be half multiplied by x to the power minus 1 over 2. If we want, we can write this as 1 over 2 multiplied by 1 over the square root of 2, or to the power 1 over 2. We already know that x to the power half is the same as the square root of x. Therefore, f prime of x is equal to 2 multiplied by the square root of x. 1 over 2 multiplied by the square root of x. In part C, now we are going to find the derived form for f of x equal x to the power minus 2. Then n in this case is equal to minus 2. Substituting in f prime of x, then n is minus 2 multiplied by x to the power minus 2 minus 1, or minus 3. Let's now write it again. It will be minus 2 over x to the power 3. We already know x to the power minus 3 is the same as 1 over x to the power 3. Therefore, part D, we have x divided by x to the power 5. This function is not the same as x to the power n. Let's work it out so it becomes on the form of x to the power n. We already know from the rule of indices, when we have x to the power 1 divided by x to the power 5, it's the same as x to the power 1 minus 5. We subtract the powers from each other. Then x or f of x equal x to the power 1 minus 5 is equal to x power minus 4. Then now n is equal minus 4. Let's apply the formula. F prime of x equal n, or minus 4 multiplied by x to the power minus 4 minus 1, that is equal to minus 4 multiplied by x to the power minus 5. X to the power minus 5 can be written as 1 over x to the power 5. Therefore, now we can say this is equal to minus 4 divided over x to the power 5. In part C, we have x, f of x equal x squared multiplied by x cubed. This is not on the form of x to the power n. Let's multiply x by x, then it will be x to the power, we add the powers to each other, then it will be 2 plus 3, the answer is x to the power 5. Now n is equal 5, therefore f prime of x equal n, or 5 multiplied by x into to the power n minus 1, or 5 minus 1, that is to say the answer is 5 multiplied by x to the power 4. As you can see, the formula is easy to apply. Let's try now part F, which is a little bit more complicated. F of x is 1 over the cubic root of x. Then f of x equal 1 over the cubic root of x. the cubic root of x is the same as x to the power 1 over 3. Let's substitute it. Then 1 over the cubic root of x, or x to the power 1 over 3. We already know this property from the first chapter. Therefore, it's easy to write it. Now we have x to the power 1 and its cubic root. It's then can be written as x to the power 1 over 3. This is equal to, let's take x to the numerator and change the power sign. So the answer is x to the power minus 1 over 3. Now x to the power minus 1 over 3, comparing it to x power n, then n is minus 1 over 3. Let's substitute, then f prime of x equal minus 1 over 3 x into the power minus 1 over 3 minus 1, then minus 1 over 3 multiplied by x into the power minus 4 over 3 is the answer for the derived form of f of x. We can rewrite it so it becomes minus 1 over 3 multiplied by 1 over x to the power 4 over 3. Using the formula, we were able to apply and find the derived form for f of x in different cases. After solving this example, we can go to set of exercises 7b, page 120, where we are asked to find the derived function given that f of x equal, and we have different examples. These examples are almost similar to the examples that we solved previously. So applying the rule that we studied, we will be able to find the final derived form for f of x.